Lesson 1, Planning a Pizza Party. Learning target, I can use letters and numbers to write expressions representing the quantities in a situation. In this lesson, we will experiment with expressions and equations to model a situation. In math, a model is a mathematical or statistical representation of a problem for science, technology, engineering, work, or everyday life, used to solve problems and make decisions. You may not realize it, but you have worked with mathematical models for many years. Expressions, equations, and inequalities are all examples of mathematical models. Today we will engage in mathematical modeling by writing expressions, equations, and inequalities to represent real-life situations. Real-life situations often involve constraints. A constraint is a limitation on the possible values of variables in a model, often expressed by an equation or inequality, or by specifying that the value must be an integer. Let's take a look at an example. Distance above ground D in meters might be constrained to non-negative values. We can express this constraint as an inequality using the variable D. Non-negative refers to a value greater than or equal to 0. Therefore, D is greater than or equal to 0 in this given situation. Let's engage in the modeling process with a real-life situation of planning a birthday party. We'll need to think about relevant quantities, whether they might be fixed or variable, and how they might relate to one another. When planning a birthday party, we might be dealing with these quantities and constraints. For this example, the number of guests. Let's assume that the maximum number of people attending the party is 20. We would have to consider the cost of food and drinks. For this example, the cost of food and drinks per person is $5.50. The cost of the birthday cake is a fixed quantity. For this party, we know we'll need to buy only one cake, which will cost $40. The cost of the entertainment is also a fixed quantity. The host will need to spend a total of $15 for music and $27 for games, respectively. We must consider the total cost of the party. This constraint is no more than $180 for the total cost of the party. We can write expressions and inequalities using numbers and letters to express constraints. For this situation, let's let N represent the number of people and C represent the total cost in dollars. Sometimes a constraint is an exact value. Other times a constraint is a boundary or a limit. For example, no more than 20 people can attend the party. This means 20 people or less can attend the party. We can represent this constraint as an inequality. N is less than or equal to 20. The expression 5 50/100ths N is a concise way to express the overall cost of the food if it costs $5.50 per guest and there are N number of guests. The cost of the birthday cake is an exact value. The cost of the cake is $40. The cost of the entertainment is also an exact value. Which expression represents the cost of the entertainment for the party? 15 plus 27 represents the cost of the entertainment for the party. Lastly, we can represent the constraint of no more than $180 for the total cost of the party as an inequality. Which inequality represents this constraint? If $180 is the maximum budget, this means we can spend $180 or less for the party. Therefore, C is less than or equal to $180 represents this constraint. Deciding how to use numbers and letters to represent quantities, relationships, and constraints is an important part of mathematical modeling. Equations can show the relationship between different quantities and constraints. For example, the total cost of the party is the sum of the costs of food, cake, and entertainment. We can represent this relationship with two different equations. Let N represent the number of people, and let C represent the total cost in dollars. We can first model C equals 5 50/100ths N plus 40 plus 15 plus 27. This equation includes all of the relevant quantities. 40, the cost of the cake, 15, the cost of the music, and 27, the cost of the games, are all fixed quantities. Since the number of people may vary, we represent the cost of food per person as 5 50/100ths N. The sum of all of these quantities would calculate the total cost of the party. We can write an equivalent equation by adding the costs of the fixed quantities together. Which of the following equations is equivalent to the equation shown below? C equals 5 and 50 n plus 82 is the equivalent equation that represents the total cost of the party. Let's take a look at one more example. We can continue using the birthday party model from the previous slide to see how we can efficiently make estimates and adjustments. A model can be an efficient way to make an estimate or prediction. For example, by writing the equation for the birthday party, we can predict approximately how much money we may spend. We can predict the cost of 15 people by substituting 15 for n. When a quantity or a constraint changes, or when we want to know something else, we can adjust the model and perform a simple calculation. For example, the equation can be used to find the total cost for different amounts of people, which was represented by the variable n. If one of the constraints changed, such as the cost of food per person is now $8 instead of $5.50 per person, we can adjust the model to calculate the cost for 15 people by writing the equation C equals 8 times 15 plus 82. To celebrate graduating high school, all of the students in 12th grade are attending a day trip to a theme park. Write an expression that could represent an estimated cost for the trip. State what each part of the expression represents. There are many possible quantities and constraints we could consider. For this example, let's consider the cost of admission per person, the cost of transportation, and the cost of food for the trip. This is one of the many possible expressions that we could represent an estimated cost for a trip to a theme park for n number of students in the 12th grade. In this expression, 50n represents the cost of admission per person for the theme park. 500 represents the cost of the transportation, and 2,000 represents the cost of lunch for everyone attending the trip. We know that n represents the number of students in the 12th grade. What are some values that would be reasonable for this given situation? The number of students in the graduating class may vary from school to school. However, it's important to note that only values that are whole numbers make sense in this given situation, as we cannot have a partial amount of a student. It is reasonable to speculate that a graduating class may be between 100 to 150 students. In the upcoming lesson, we will continue to write and interpret expressions, equations, and inequalities that represent situations and constraints.